Okay, we're going to talk about solving compound inequalities today. I'm warning you this video might get a little lengthy, so I'm trying to rush through, but if you need to pause or rewatch, please feel free to do so. So here we go. We're going to talk about solving compound inequalities. Yesterday we talked about how you have two options, the and the or option. We're going to start by talking about your and option. You need to write down what I'm writing in the box. This part up here is just an example of what a possible compound inequality might look like. Usually an and compound inequality is not going to physically have the word in it. Every once in a while it might, but probably not. Instead, it's going to have the two inequalities with a variable in the middle. And inequalities happen when both of these two things are true. They're known as intersections. And then remember, when you're graphing an and inequality, you're going to have two lines. Let me get my pen. You're going to have two lines. So one's going to start here and go this way. One's going to start here and go this way. And what we really want to know is what's happening when they intersect or when they meet. And any of these numbers that fall in this intersection where they meet, those numbers would make your inequality true. We're going to come down and we're going to start, ignore the fact that my pen is going crazy right now. We're going to come down and we are going to talk about steps on how to solve an and inequality. Like I said, usually your and inequalities are not going to actually have the word and in them. This first example is easier, and so it does have the word and. But here are going to be our steps. Usually, we're going to have to split our inequality into two different inequalities. So split into two inequalities. And I'm just going to abbreviate that. Like I said, we're lucky because we already have the two. We have n minus 2 is greater than negative 3, and plus 4 is less than 6. So we already have them split into two. The next two examples, we're going to have to change this up a little bit. Step number 2, make sure that you rearrange so that your variables, if you only have one for each one of these, is on the left. You want your variables on the left, which remember we talked about that because when we go to graph, that's going to make our lives easier. So if you need to rearrange and flip things around so you get your variables on the left, you want to do that. Step number 3, we are going to solve. The same rules are still in effect that we've been working with for the last several days. Remember, if you divide by a negative or multiply by a negative, you got to flip your sign. We have to solve twice. We have to solve for the first one and the second one. So you can just draw a t-chart. I'm going to add 2 to each side, and that's going to leave me with n is greater than negative 1. Over here with my t-chart, I'm going to add 4. That is going to leave, I lie, I'm going to subtract 4. Error. And I'm not going to redo the video for that. I'm going to subtract 4 to get it to the other side. Sorry. So that's going to leave me with n is less than 2. At this point in time, when you have 1 and 2 answers, you're going to do step 4, which is graph. You want to graph right now, not at the very end. So let's say this is 0. So that would make this negative 1, and that would make this 2. I'm going to put an open circle at negative 1. I'm going to put an open circle at 2. When I go to graph negative 1, it wants me to go to the right, so I'm going to graph to the right. When I graph from 2, it wants me to graph to the left, so I'm going to go this way, and this is my graph. So the answer to this compound inequality is any number that falls in between negative 1 and 2. So negative 1 doesn't count because it's not filled in, but 0 would count, 1 would count, 1.5 would count, 2 doesn't because it's not filled in. Now, this is the part that's tricky. So this is going to be your step number 5. You have to write your answer in set notation. And part of set notation in this situation is creating a compound inequality. That is going to be our tricky part. So when we write our answer, we have to write it as a compound inequality. So this is how it's always going to be set up. You're going to have your variable in the middle. You're going to have your inequality signs, and you're going to have a number and a number. This is going to be your smallest number. This is going to be your biggest number. And this pattern is always going to work for when you're writing compound and inequalities. So I'm going to start and put my n in the middle because that's my number. 2 is big, negative 1 is small. If I go up here and I look at my two answers, the n is less than 2. That's exactly how it will look here, so I can just pull that sign down. When I go look up here, though, n was first, and my answer, n, is going to happen second. The negative 1 came first. So since negative 1 came first, we have to flip the sign because we flipped the order. think of it as the inequality was opening to the end, it's still opening to the end. So we just created a compound inequality. We're going to draw our set notation in, draw our squiggly brackets, and that's our final answer. All right, we're going to move down to the next one. So the next two are going to get a little more tricky because neither one of these have the word and in them. Instead of having the word and, we actually have two different situations happening here, but it looks like one. So my first problem that I'm going to see is this 4 is less than W plus 3. That's my first inequality. My second one is going to start here and go this way. W plus 3 is less than or equal to 5. So you're going to have to split it up into two. So let's start with the first one. 4 is less than W plus 3. And then W plus 3 less than or equal to 5. So this middle section is what you're going to see repeated twice because it applies to both of them because it's a both. If I look at this first one that I wrote, I don't like this because my W is on the left, is on the right, and I want it on the left. So I'm going to flip-flop this. Change my sign, and I can solve it. I'm going to subtract 3, subtract 3. My W is greater than 1. Same thing over here. I'm going to subtract 3, subtract 3. My W is less than or equal to 2. At this point, you want to graph. So I'm going to say that this is 0. I'm just making up my spots. This is 1. This is 2. If you wanted to spread them out more so the graph's prettier, you could. I want to graph at this point, not when I write my compound at the end. I'm going to put a circle here. I'm going to put a circle here. My circle for 2 is going to be filled in because there's a line underneath it. At 1, I'm going to the right. At 2, it wants me to go to the left. So that means that the answer to make this inequality true has to be any number that's in between 1 and 2. 1 doesn't count, 2 does. If you wanted to, you could check yourself. So let's say we pick 2 because 2 counts. So if I put 2 here, that means this would be 5. So that means that 4 is less than 5. Well, that's true because 4 is smaller than 5. Or 5 is less than or equal to 5. That's true because it's 5. So that means that both of these situations are true if I use one of the numbers that fits on my graph. Now we got to do our compound inequality. I'm going to put a W. I'm going to put my biggest. I'm going to put my smallest. My sign here can stay the same because W is first. My sign here I have to flip because we flipped the order. 1 is coming first, so the inequality has to open up to whatever it was opening up to originally, which was the W. I can draw my line, I can put a W, and I can do my squiggly brackets. And that's my final answer. I want you to see if you can do number 2 by yourself. I'm going to pause the video, you're going to pause the video, and when we come back, we'll walk through the steps. Okay, we're back. Hopefully you have already solved number 2. I'm going to just kind of quickly walk you through my process. So I broke this down into 2 different inequalities because it's an and. So the one I underlined in black and then the one that I underlined in purple. The middle section is the section that's going to be a part of both of them. So when I solved for the first one, since there's variables on both sides, I don't have to worry about flipping. I just know I've got to move my variables to the left. Since I ended up with -5, when I divided, I did flip my sign. When I come over here to the purple one, I moved my D's over, and then I moved 12 over, and I ended up with 5. So I have -3, I have 5, and we're actually ready to just graph this really quick. So let's say that I'm just going to put these on this line really quick. If you want to count, you can. I don't know that they'll both fit on here if you actually counted them, but I'm just going to throw them on really quick so the video is shorter. I'm going to say that my -3 is right here, and I'm going to say that 5 is right here. Like I said, I know that's not enough distance. I'm just throwing them on the number line so that they'll fit. When I go to graph this, and you should be more precise than I am. When I go to graph this, I'm not going to have anything filled in here. I'm not going to have anything filled in here. My -3 wants to go this direction. My 5 wants to go this direction. So anything in between -3 and 5 is going to make my inequality true. This is my graph. So now I have to come up with my inequality, my compound inequality. D is in the middle. 5 is my big number. -3 is my small number. I can look at this inequality over here and it's the same order, so that's going to go this direction. When I look at this inequality, the D was first. When I look over here, -3 is first, so I have to flip my direction. Draw your line and your D and your squiggly bracket, and that is your final answer. Go ahead and flip your paper over to the back. So on the back, we're going to talk about ORs. That should say option 2. I will fix that on your paper. We're going to talk about ORs. So when we're talking about ORs, it's going to physically say the word OR in it. It's not going to be like and where it's just like, wait, what the heck's happening? If you remember, an OR is known as a union. And that means you have a couple options. Option 1, the first one is true. First inequality. Option 2, the second inequality is true. And then every once in a while, option 3, both of them are going to be true. Your graphs can look one of two ways. You can have a line going this way, a line going this way. Every once in a while, you might have one that looks like this, where like the first one was here, the first number was here, the second number started here, and it's anything going to the right. Every once in a while this happens, but usually it's going to look like the first option. I'm going to do the first example with you, and then you're going to do the last two by yourself. So my steps are going to be pretty much the same. So they're already split into two separate inequalities. So I'm never going to have to do that with ORs. So first thing is make sure you rearrange so that your variables are on the left, like we did on the other side, and like we did the last several days. Remember that this rule doesn't apply if you have variables on both sides of your equation. Second thing, you're going to solve each inequality. So you're going to be solving for two things, but they're all already split up for you, so that makes your life easier. I'm not going to spell inequality out. So I have this one, and I have this one. When I look at my first one, my variable is on the left, and is on the right, and I only have one variable, so I'm going to flip this because this is going to make graphing easier. The second one is already set up nicely. I'm going to solve. This is a +3 I'm dividing by, so W is greater than 1. When I divide by 3 here, I'm going to get that W is greater than or equal to 3. So these are my two options. So we're going to graph, which is our third step right now. Remember, it's easier to graph before you combine them together. So let's say that this is 0, so then this would be 1, 2, and 3. I'm going to put a circle here, not filled in. I'm going to put a circle here, and I am going to fill it in. This one says W is greater than 1, so I'm going to start going this direction. This one says that W is greater than or equal to 3, which is also going this direction. So my line is going to keep going this way. So this is an example. This should be an arrow. This is an example of one of the ones that we had not seen before, but this is still considered an OR. Like I said, this would be like the second graph. I want you to solve the next two without me. They're already split up for you. And then we'll reconvene and we'll talk about writing compound inequalities for these as your answer and what your final answer was.